Hello everyone, I'm Eli Hanouj, a MongoDB champion, one of the authors of MongoDB 7.0 Mastery Book, a senior software engineer and a technical product manager from Lebanon. And I'm happy to be with you in this session and in the following sessions in this series where we will build together an airline ticketing system using Rust, a beautiful, powerful programming language, and MongoDB, a leading NoSQL database. I recommend before you start this series to gain the basics knowledge about Rust, how to install it and to do the basic setup by following their documentation, and to have minimum knowledge about MongoDB, which you can gain from mongodb.com, MongoDB University, MongoDB YouTube channel, and even our Lebanon MongoDB user group YouTube channel. In this session, as the first session in the series, we will start by creating a new Rust project using Cargo, the build and the package manager that Rust have. We will do the folders structure and we will start creating our database models. So let's kick it up. The first step is to open the command prompt and to create a new project using the Cargo package manager by saying cargo new to create a new project airline dash ticketing system and clicking enter. As you can see, a project got created. Let's open it, airline ticketing system, and let's open it in Visual Studio Code. Amazing. As you can see, after we did the basic setup and created a Rust project using the cargo new command, we see here the setup. We have the source, the target, the .getIgnore, the cargo lock, and the cargo.toml. The source is the place where the main.rs, which means Rust, will live, and the other files and folders that will contain the business logic, the code, and all the components of our project will be there. On the other hand, the target folder is a directory created by Cargo automatically and which will contain all the compiled output, intermediate files, and other build artifacts that will be generated each time we test, build, or run our project. So, as a first session in the series, we will not go into the darket folder as we will be touching it in the coming sessions. Cargo toml is a very important file which we should take care of in our project, which is the configuration file for the Rust package manager. It contains the project metadata, the dependencies, the build settings, and for people familiar with Node.js and the NPM ecosystem, it's similar to the package.json. On the other hand, cargo.lock is the file that Cargo use to record the exact versions of the dependencies used to ensure a consistent build. For example, if we're installing a specific version of MongoDB driver for certain reason, this cargo.lock will include this specific version. Why? To ensure once we need to deploy this project from an environment to another, that all the build settings remain consistent. As a first step, we will start by adding the dependencies that we may need. And this is a growing file. We will start with what we need in this session, and in the coming sessions we will add. Dependencies are split between different type of dependencies. These dependencies which our project need to run and to execute the build. Where on the other hand we have the dev dependencies which we as developers may install and use locally just for our productivity or as helpers, and that will be excluded once we need to deploy our project. So in the main dependencies, we will start by adding MongoDB driver by saying MongoDB equal and mentioning the version 2.8.2, which is the latest version. We will be adding Serde and third JSON. What is third and third JSON? Third, it's a powerful framework for serializing and deserializing Rust data structures. It's designed to be generic and support various data structures, you know, not only JSON. On the other hand, third JSON is a craft that provides support for serializing and deserializing what JSON data using the Serde framework. So Serde JSON depend on Serde to give us the ability to serialize and deserialize a JSON data. So you can say Serde JSON is the child of Serde. It's a specific implementation of Serde that is specified for the JSON format and that we will use in the session and in the coming sessions, of course. So to add them, we will say third equal. We'll open the curly brackets. Why we're opening the curly brackets? Because I need to specify the version and the features. Okay, version equal 1.0, comma, features equal. We open those brackets and we say derive. Then we will add the JSON, which is the specific implementation of Serde. Serde is generic. It works with JSON and other data types, where Serde JSON is only for JSON data types. All right, and then we will save our file. In the source folder, we have the main.rs, which is the entry point, the executable file that we have, which contain by default print ln hello world to print on the console a hello world message, which we will not take care of currently. Let's create inside the source a folder called models. In this models, what we will do is we will start creating our database schemas. And for an airline ticketing system that will grow from a session to another, we will start with the basic data models, which are the user model, the seat model, the flight model, and the booking model. And as we go and as we explore the business logic behind this airline ticketing system, we may need to add more models and do the relations between them. And for people who don't know how data modeling in MongoDB go through embedding and referencing, I recommend checking MongoDB official website, the amazing documentation, the MongoDB University, which give you plenty of free courses that take your career from zero to hero. So let's start and let's add user model.rs. Let's add booking model.rs. Let's add flight model.rs, and let's add the seat model.rs. Now we have four different files. Each one of them will have the specific data model or data schema details that we will work with. Starting with the user. Let's start defining the dependencies we need. We need to use Serde. So we say use. Let me increase the. Okay. I think this is better. Some zoom. We say use Serde. And this way we open the curly brackets and we say serialize, comma, deserialize. Okay. And we put a semicolon because we will need to use the serialize and deserialize from the third framework. Use MongoDB. And from MongoDB, we need to use Bison OID object ID, as we need the object ID to create a new IDs for the documents. Use, and I think we will use also the validator to add some basic validation. So let's add it from now. Let's add the validator to the cargo.toml, which is here validator equal 0.14. And you can see all of those details from the cargo website, where you can search the different packages. Save. And then what we will do is we will use this validator because it will be an important uh, package for us. Use validator, and we need to use the validate and the validation errors from it. After that, we'll start building the user struct for our user. And the first step is to add what? The attribute, which is the derive attribute, which give us the ability to implement certain treats for our struct. As we're using serialize, deserialize, and validate, if we use the derive keyword in Rust, we will have the ability to automatically implement treats for our struct. And to do so, it will be as simple as before we create our struct, say derive, and after saying derive, we need to say serialize, comma, deserialize, comma, validate. And this give us the ability to automatically give Rust the ability to what? To implement certain treats for our struct, which will be the user struct type. So we say pub mean public because anything that we don't put pub for will be private, and we needed the user struct to be public and accessible outside the file. So pub struct user, we open curly brackets, and we start defining our attributes, the model attributes or field that we want to work with. And here also we will use Serde because we will start working with pub ID, which will be an object ID. So here we need to define for each user an ID, and this ID we needed to be of object ID type, which is the type that MongoDB give to its IDs, to the automatically generated IDs. And because we're putting ID without underscore, we will use the third treat to rename it while the generation process happened by saying third rename equal underscore ID. And what does this line of code do? We will explore more amazing Rust features as we go, but this third line will give us the ability to rename this pub ID to underscore ID once creating a new instance of this user. Then, comma, and we will need to, for example, have username, password, email, whatever. So we will say pub username, and this username need to be of type string, for example, and we need to have some validation for it. We will not deeply dive into the validations from the first session, but basic validations by saying validate, and in the validate, we will mention that lengths should be of minimum equal 5, which will ensure that no username can be created with less than 5 characters and no username will be empty. For example, more advanced validations will go through once we advance in this amazing long-term course. Okay, and as you can see, we put the validation before the definition of the property that we're working with. After doing this, we need to, for example, have password, which will be also password, which will also be string. Okay, and this may have, for example, specific lengths based on the business requirements. So for example, let's say it should be of minimum of 10 characters. So any password that have minimum a length of less than 10 characters will be rejected. We need to have a role, an email, pub email should be a string, pub role, which was a string, and so on. We can have a full name, a phone number, and whatever we want. Let's keep it simple as we will have more attributes and more fields once we start building the functionalities that the system need. But one specific main attribute that we have and that we will put is bookings. Each user will have multiple bookings. A user may have one booking, two bookings, an amount of bookings. And each booking is a MongoDB document that will live in the booking model. So the booking here should be an array or in Rust a vector of type what? Of type object ID. Why we need to do that? Because we need to build this relation as a reference relation. So each time a user have new booking, we store the booking ID inside the array of bookings. And each time this booking details, we only reflect them in the booking model. And here we refer to them and we populate them once needed. So to create an array or a vector of bookings, it will be simple as saying pub bookings vec, which is a vector, then object ID. Why object ID? Because it's not an array of string, it's not an array of integers, it's an array of object IDs because it will hold the object IDs that the bookings will have. And we can put a note here, a reference to booking documents. And this is a basic user struct that we may have. After creating or defining the struct, what we will do is we will create an implementation for this user. And what does implementation mean or IMPL mean? It's a keyword used in Rust to define implementations for a struct or an imam or a treat. It allows us to specify the methods or the functions, if you want, associated with this type. Because here, once we say struct user, we're defining a type. And once we create an implementation, inside this implementation, we can specify the functions or the methods associated with this type. And to do so, we'll say IMPL, which is short of implementation, user, then we open curly brackets. Inside it, we will create a constructor, which is people who know OOP, and I recommend you to understand a bit of OOP also, will know what is a constructor. So We'll create a constructor, a public constructor, by saying pub fn, and fn is a keyword used to create a new function. Then we will say new pub fn new to create a constructor that give us the ability to create new instances following certain criteria or certain params. So we will say username, which is a string, password, which is a string, role, which is a string, email, which is a string, and we will create this user constructor without any uh, without any booking in the params. Why? I'll give you a minute to think of it. So why? I think you guessed why. Because once creating a new user, we don't want to force this user to have bookings. They may have an account in our platform and they may don't have any booking on the first place. Then we will say that the result will be self, comma, validation errors. What does this mean? Let's explain. So we created a new function that accepts those parameters and return a self as a return type or validation errors. So what is the result self comma validations error? This gives us the ability to specify the return type or the result type of the execution of this function. So the result, which will be either an enum, okay, which is okay self, which indicate the success and contain the new instance of the struct, because self refer to the instance created itself, or what it will include, the validation errors, which indicate the failure and contain validation errors. So the result, guys, it's an enum that will either contain okay self, and this okay self will contain the user created itself, or it will contain error validation errors, which indicate the failure and contain the validation errors behind this validation result. Then here we will say let user equal user in this way, and we will start with ID, which will be object ID in this way new, because we need a new object ID for this ID, a username, a password, a role, an email, and finally an empty bookings vector by saying this. After doing that, we'll put a semicolon, then we will say user dot validate. We'll put exclamation mark and semicolon. What does this line do? It simply gives us the ability to validate the user instance. Okay, then we will say okay user, which what do return the valid user instance. So either a validation error will be returned and the instance will fail, or a valid user instance that got created will be returned to us. And this is the first model that we create in this amazing tutorial. Let's move on and let's create the flight model, or before the seat model. Let's start with the seat. Let's close this, or let's just take the basic things that we may need from here and use them here in the seat model. Then say derive in this way, then serialize and deserialize. And what we need to use the serialize, we need to use the deserialize, and we need to use the validate, of course. Copy paste it and start by saying a pub struct seat and open the curly brackets, then say serde rename underscore id, which give us the ability to rename the id to underscore id once generating a new instance or a new document, and say the id is an object id. Then we need a pub seat number, for example, which is simply a string because it may include, for example, A10 letters and numbers, so it should be a string. Pub available, does the seat still available or no, which is a boolean. And let's put a quick validation for this string for now. We're not focusing on all the validations on the first run because we will deep dive into them, and we will say minimum equal 1. Then we're done, and then we will create the implementation. And as a side note, inside this implementation we can create more than one function, not only one function, but for now the only thing we need is one function, new seat number, which is a string. We need also available, which is a boolean, and the result will be what? Either self, which is instance itself, or validation errors. Let seat equal seat, then id object id, and after doing that we say new, then we pass the seat number and we pass the available semicolon, then seat dot validate, and then okay seat, and this is it. Let's copy this again and go to the flight. It's easy and simple, and for now you know how to do them. Let's put it, and let's start with pub struct flight, and this flight contain, let's copy this, speed it up, then say pub id, which is an object id. We need to do pub airline, which is a string, the origin of the flight, which is a string, pop destination, which is also a string, the departure time, the arrival time, the status, pub departure time. We need to have it as date time. How to do that? Let's do it here in Bison. Let's remove those and say it like that. OID object ID, comma, date time to include the date time. Then here we say date time, pub arrival date or arrival time, which is date time. We need to have a status, which is string departed, landed, or whatever, and the seats, which is an array or a vector of what? Object IDs. Then what we will do is create an implementation, and inside this implementation we will create a public function new, which give us the ability to create a new instance when using this struct airline string origin string destination string departure time date time arrival time, which is date time, and the status, which is string, and of course some seats, because each flight will have seats, which is a vector of what? Of object ID. Then we will return a result, and in this result we will have self, comma, validation errors. Then we will do that and say let the flight equal flight object ID, and of course a new, then airline origin destination and so on. Departure, I think, departure time, sorry. Okay, arrival time, status, and seats. Then curly bracket and flight dot validate here to validate this, and then say okay, flight, and save. And this is it. So far we have user, seats, and the flights done. The final one will be the booking which will include, let's take those from here because just you already mastered them. Then say pub struct booking, and inside it we will just put third rename to rename the ID to underscore ID as mentioned before. Alright, then pub ID, which is object ID, pub flight ID, which is an object ID, and this will reference to what, guys? Reference to flight model. Pub user ID, which is the user who did the booking. Of course, here we missed the comma. Sorry, we need the seat, which is an object ID. Also, this refer to user model. This refer to seats model. Then we need the status of the booking, if it's booked, cancelled, confirmed, or whatever, and the booking time, which is date time. Of course, we can add more like payment details, like the amount the user paid, if there is a coupon or there is a certain discount, and all of that we will reach hopefully once we expand this tutorial and go into the implementation part of the functionalities where we will re-add some new models to extend the functionality. In this specific booking model, I'm not gonna implement the booking for you. What I'm gonna ask you is to take it as a challenge, implement it as you will find the solution for it, where in the coming session you will find it already here. Implement booking and add the new function that give us the ability to create a new instance to do the validation as we did in the other models. This is everything for this session, where we explored how to set up a Rust project, how to add MongoDB and other packages in the dependency cargo.toml file, and how to create MongoDB models or schemas in our project. In the coming session, we will solve this small challenge that you get. Then we will go and create the controllers folder, which will contain the functionality of the booking, the flights, the user, the authentication, the GWTs, and very interesting advanced MongoDB features will be used, and the Rust techniques and Rust features will be used. And as we progress in this series of sessions, you will each time learn a new MongoDB features and the new Rust features. I recommend also to go over the Rust documentation to learn the basics if you don't know them, and to learn some basics of MongoDB from Lebanon User Group YouTube channel, or MongoDB University or MongoDB YouTube channel. Stay safe and enjoy this session, and see you in the coming session. Ciao.